Hi, my name is Ying. In this video, I'm going to show you how to express the chemical equations to a balanced chemical equation. In a chemical reactions, atoms are neither created nor destroyed, which means a chemical reactions must have an equal number of each type of atoms on both sides of the reactions arrow. Let's begin by looking at these chemical reactions. We have hydrogen gas and oxygen gas combined to make water. This is how we can express the chemical reactions using words. We often call this a word equation. Now we can use the word equations to express and write it in chemical reactions by taking each of these molecules and write it using a chemical formula. For example, hydrogen plus oxygen to form H2O. If I want to be more precise, I can also indicate the states of each compound. In this case, I have hydrogen gas, I have oxygen gas, I have water in the form of liquid. Now before we start, we're going to start by listing the amount of atoms on each side of the reactions arrow. On the reactant side, I have 2 hydrogen and 2 oxygen. On the product side, I have 2 hydrogen and 1 oxygen. Now looking at these equations, as you can see, we have 2 hydrogen atoms on the reactant side, we have 2 hydrogen atoms on the product side, which means hydrogen is balanced. Now the next step is to look at or to balance the oxygens on the reaction side and also the product side. In order to balance the oxygen atoms, we will have to put a coefficient of 2 in front of the H2O. In this case, we have increased the number of oxygens by 2, and that gives me 2 oxygen atoms on the product side. By putting the coefficient of 2 in front of H2O, I not just increased the number of oxygens on the product side, I have also increased the number of hydrogen atoms on the product side. In this case, I would have a total amount of 4 hydrogen atoms on the product side. Now looking at this equation again, hydrogen atoms is no longer balanced. Therefore, in order to balance hydrogen atoms, we will have to put a coefficient of 2 in front of H2. The reason why I choose a coefficient of 2 for hydrogen is because each hydrogen molecule has 2 hydrogen atoms. In that case, I will have a total of 4 hydrogen atoms on the reactant side. Now as you can see, the number of atoms on both sides of the reactions arrows is balanced. And I can say that this chemical reactions is correctly balanced. Now the last thing to check is to make sure that the coefficient of these chemical reactions is actually at the lowest ratio. Now having a coefficient that is not at the lowest ratio in a chemical reaction does not mean that this chemical reaction is not balanced. But however, we prefer to write a chemical reactions at the lowest ratio typically. Going back to these chemical reactions, I'm going to share with you some common mistakes that a lot of students did when they first came across with balancing chemical reactions. And they say, hey, there's a much easier way to do this. In order to balance the number of atoms on each side of the reactions, I can simply add a subscript of 2 on this side. And as you can see, now we have 2 oxygens on the product side. I also have 2 oxygen on the reactant side. In other words, I also have 2 hydrogen atoms on the product side. I also have 2 hydrogen atoms on the reactant side. Unfortunately, you can't do that in a chemical reactions. Because in this case, in these chemical reactions, we are forming water. But when you add the subscript into this formula, you are changing the identity of this compound. this is no longer a water molecule, it's hydrogen peroxide. So therefore, the take-home message is you can only change the coefficient while balancing chemical equation. You can never change the subscripts, because if you change the subscript, you are changing the identity of the compound. Now let's try to balance another chemical reactions. We have methane plus oxygen to give us carbon dioxide and water vapor. Again, we're going to start by listing how many atoms on each side of the chemical reactions arrow. On the reactant side, we have 1 carbon, 4 hydrogen, and 2 oxygen. On the product side, we have 1 carbon, 2 hydrogen, and in total we have 3 oxygen atoms. In this case, we have 1 oxygen atoms in H2O. We have 2 oxygen atoms in CO2. Now looking at these equations, we can see that carbon is actually balanced. The next thing we need to balance is hydrogen atoms and also oxygen atoms. Now which one should we start? The tip is we start with an element that appears in only one compound on each side of the chemical reactions. In this case, hydrogen only appears once on the methane and appears once at H2O on the product side. So therefore, we're going to start balancing hydrogen atoms. In order to balance it, we will have to add a coefficient of 2 in front of H2O. And that means we're going to have a total amount of 4 hydrogen atoms on the product side. Now by putting a 2 in front of the coefficients of H2O, we are also increasing the number of oxygen. So therefore, in this case, we're also adding 2 moles of oxygens on the product side. In that case, in total, I will have 4 oxygen atoms. So in this case, I will then have to balance oxygen atoms on the reactant side by adding a coefficient of 2 on oxygen gas. That means I will have a total of 4 oxygen atoms on the reactant side. And now we can say that this chemical reactions is correctly balanced.